Hi guys, I'm back. Another chi-square test for you in our final chi-square test, okay? Today we're gonna talk about the chi-square test for independence. The key here now, again, we talked about homogeneity. Homogeneity has one sample, one variable. That was the hockey player, right? The hockey players, 80 hockey players, when were they born? Okay, that was their one variable. Next, we talked about chi-square homogeneity. We had two samples or more, sometimes it can be. That's where we had kids who were taking acetaminophen versus ibuprofen, okay? Those are the two samples. Then what happened? The one variable, their adverse effects, okay? Now what do we have today? We have one sample, but now we're looking at two variables within them. And there's some keywords in here: relationship, association, independence. Below is a table that shows the results of an investigation between the relationship between gender and having allergies for a random sample of 40 students. So that's my one sample right there, who completed a survey at school. Do the data provide convincing evidence of an association between allergies and gender in the population of interest? Here are my table. Now notice I don't have any totals. I don't have a row total. Oh, I'm sorry. I do have row totals. I don't have the column totals. So we can go ahead and we can fill those in real quick just so we can see them in case we have to do anything with it. Females, we have 23. Males, we have 17. Okay. And then together we have, oh dear, something is off here. 10 plus 8 is 18. 13 plus 9 is not 33. 13 plus 9 is 22, okay? And then together, so cross that off there. Who came up with this example? It was me. Together, then that gives us 40. Perfect, okay. All right. The question then is, do the data provide convincing evidence of an association? So what does an association means? We want to know if it's independent or not independent, okay? Association means independent. So is it independent or is there not independent? Again, staying consistent in all chi-squares. HO is an is statement, HA is an is not statement. Now, there's other ways you can do this. However, I like that way because you can always think is not for all of them and you don't get confused. In my experience, if you do it in another way, people get confused more often than not, okay? Not a big deal though if you're working with other people and they do it a little different way, doesn't mean that they're wrong. So our HO, let's start there. What's going on? We're looking at allergies and gender. The distribution of allergies and gender are independent. So I'm going to underline some things right now for us. Allergies, gender, those are the two variables I'm looking at. So you just fill that in every single time. It's the same. The distribution of allergies and gender are not independent, okay? Makes it easy. They are independent, is, aren't, is not. Distribution of the two variables are independent. Distribution of the two variables are not independent. Again, I'm going a lot faster than I would teaching, just really making sure you guys that you're pausing along the way and writing down any questions to ask me when you're done. Off to the plan where we're gonna keep it real when we're talking about chi-square. We have a random sample of 40 students. It is not an experiment, so we just do it the normal way. We take 10 times 40, that's less than all students, we assume. And then again, our expected counts in the table above have to be greater than 5. Now, I'm gonna solely do this on the calculator right now, not like homogeneity. I showed you how to do it out by hand, okay? For the L, I'm gonna suggest that you go to the do and then come back to this. My fear is you're gonna forget to come back, but let's go through it together and we'll figure it out. Our method is a chi-square test for independence, and I do have that expected count formula there. We're gonna let the calculator do it today, but just as an added bonus that, hey, you have to have this memorized. Okay, we are on the do. So we're gonna run the test and write everything down. I'm gonna go to my calculator. It's the same thing for homogeneity. So my calculator is right here. I am going to go now to the matrix editor. So second x to the negative 1. I'm going to arrow over to edit. I'm going to edit my matrix. I'm going to scroll up. I believe I have a 2 by 2, but let's just double check. We do. We have a 2 by 2. Okay. So I'm going to fill in my matrix. I have 10 females. Oh, come on. 2 by 2. There we go. 10 females. Oh. 13 females. 18. And 22. Okay, so what did I put here? Let's just look. I'm gonna run the test, okay? So I have it in. I'm gonna go ahead, I'm gonna go to stat. I'm gonna arrow over to test. And I'm gonna scroll up and I'm gonna do that chi-square test again. Same for independence and homogeneity. I'm gonna hit enter. My observed is A. I don't have to do anything with B. Again, I wanna be clear, that's a question that comes up a lot. It will automatically compute those expected counts and put it in the B matrix for me. So I just scroll down and I calculate, and then I use my fanciness here. That is a large p-value. Holy smokes. I hope I typed it all in. For time's sake, I'm not gonna well, yes, let's double check. When you get a large p-value like that, I think it would be prudent to just double check that you entered your matrix incorrect. 10, 13, 18, 22. And, oh, there we go. Look what I did. Okay, so maybe you caught me doing that. I accidentally put in the totals instead of the males and the females, okay? So just a lesson to be learned there is if something seems off, go ahead and double check it. That's a huge p-value. And I was gonna, because I wanted to be done for you guys, I was gonna forget it, but I'm glad I went and double checked. Okay, so that should actually be not 18 and 22, but 8 and 9. Okay, now let's run the test. So stat, arrow over to test. I'm gonna scroll up. What am I doing? Forgive me. There we go, chi-square test. I'm gonna go down, I'm gonna calculate, and that seems like still a very big p-value. But we know that we entered it in right, so we're gonna stick with it and go from there. And I have my fanciness, and I'm gonna bring it down. And I'm gonna cover up my other one, because that's wrong. So we ran the test, and we're gonna write everything down. So I'm gonna do that right now. Chi-square is equal to 0.0506. My p-value is equal to 0.82196, okay? And my degrees of freedom is equal to 1, okay? So what I did is I just wrote everything down. And now what I want to do is I want to fill in the test. So you can see that here. Run the test, write everything down, and now don't forget to go back and fill in your expected counts. How do I get those expected counts? I go to my calculator, I go to second x to the negative 1, I go to that b and I hit enter. I hit enter again, and there's my expected counts. So I'm gonna use my fanciness, I'm gonna bring it over. Now, to save some time right now, I am not going to write it down. Just for the video, you should. In your table, you need to write in parentheses. I lied, I'm gonna write it down. I just can't skip a step, you guys. So I have 10.35. I'm going to write it in parentheses so the readers, the AP readers know that these are my expected. 10.35. I have 12.65. 7.65. And 9.35. Now, I'm actually really glad we wrote this down because I want you to look at something. 10, 13, 8, and 9 is what we observed, okay? Our expected is what should happen if the null hypothesis is true. Look how far off the observed is from the expected. It's really not far off one bit, which tells us we don't really have much evidence that the distribution of allergies and gender are not independent. There's not much difference there, okay? Because they're the same, and that's telling us because they're the same, really, it looks like there's no evidence that it's not independent, okay? It matches up really well. Chi-square, you're always looking for that contribution, like what cell contributed most to that high chi-square value. If you have a really high chi-square value, you're gonna have a really low p-value, okay? And so when that happens, that's when you're gonna reject the null. We're not gonna have very high chi-square value there, and we can look that down there to see. It's 0.05, which does make sense that your p-value is very high then. If you have questions, make sure you pause again. Let me know. I'll get back to you. Let's go back and let's finish that do. So we ran the test. We wrote everything down. We filled in our expected counts. We named the method already. One thing we did not say, and we already wrote expected counts in table above or greater than 5, so we're okay. Then we need to show our work, the chi-square, okay? So let's do that now. I'll get up. Chi-square then. I'm not going to rewrite down the formula. It's the same formula for all chi-square. Observed. So what we observe is 10 minus 10.35 squared divided by 10.35 plus, next one, 8. I think it's 7.55, but I want to be sure. 7.65, I'm glad I was sure. Divided by 7.65 plus 13 minus 12.65, I believe it was. And then finally 9 minus 9.35 squared divided by 9.35. And now we just have to conclude, right? Because our p-value, what did I put, 0.822? Yeah, that's fine. Because our p-value is approximately 0.822, which is greater than an alpha of 0.05, we fail to reject the HO. We have no evidence that the distribution of allergies and gender are not independent. So our first sentence, like normal, is always about HO. Do you have evidence for? Or no, or do we have no evidence? I'm sorry, let me rewind. Our first sentence is always about HO. We look at our p-value compared to our alpha. We either reject the HO or we fail to reject the HO. Our second sentence is always we have evidence for HA or we have no evidence for HA. The second sentence is the one that has to be in context. All right, guys, I was 6 minutes shorter than the last video. I'll keep trying to get shorter for you. Only for the fact is I know that you have so much on your plates. Signing off from Mrs. Opal and oh, my daughter's shy. Okay, take care, you guys.